Hello, my name is Alina Jimenez.
And I'm Milani Murillo.
And today we will be interviewing Danielle Buckley on what she knows about quantum dots. Hello, I'm here with Danielle Buckley. I'm wondering what you do here at CU.
Okay, so here at CU, I study these things called quantum dots because we think that these dots, we might be able to have a material that makes more efficient solar panels, so it would be cheaper, more energy.
So what are quantum dots?
Well, quantum dots are tiny pieces of semiconductor material. So I should explain what a semiconductor is. You might be used to seeing things like conductors, like metal, that conduct electricity really well. And then there are other things called insulators. And insulators, something maybe like styrofoam, where you're not going to conduct electricity. So semiconductors are something in between. These semiconductors can be made out of different materials, like silicon, which is what's used in solar panels that you usually see today, and they can also be made from a mixture of different chemicals or chemical elements. So the type of quantum dot that I work with is lead sulfide. So that's made up of lead, which chemists abbreviate as Pb, and sulfur, which we abbreviate as S. Whenever you talk about a semiconductor, the way lead sulfide actually looks, it's what we call a crystal lattice. So that each lead is connected to 4 sulfur when you're looking at it straight on. And this goes on in 3 dimensions. So now when you talk about a tiny piece of semiconductor like a quantum dot, it actually takes this spherical shape, so you can't even see an individual quantum dot on its own. So now quantum dots are tiny pieces of these semiconductors that are so small that they act differently than whenever we look at a big chunk of like silicon or lead sulfide. So quantum dots act differently, and we think that the way they act differently, we can actually make a lot of electricity out of just a small amount of sunlight.
How do you handle quantum dots?
In here, and then I close it. And it's what we call airtight, so it seals really well. And the only thing in the chamber right now is argon gas, which is an inert gas. And so now I can open it and bring it out into the atmosphere where there's oxygen. And I can go back and forth between outside and inside the glove box, but when I'm outside the glove box, I just have to make sure I have my samples sealed.
Next we go to Tiffany and Celeste to learn about the future of lasers.
There are many things today that use lasers, including eye surgery and other medical procedures.
Lasers are also used for DVDs and military guns.
Well, that's just a little bit of what Daniela does here at CU. Back to you guys. Thank you for watching TE News.
Tune in next week and have a nice day.